Looks like we have another improper integral. What are we gonna do? Okay, this is an improper integral, as the lesson implies, that has an infinite discontinuity. So you look at the function that you're dealing with, look at the problem, and you say, oh, well, I can't divide by 0, but I'm supposed to go to 0. What do? You go to 0 with a limit. So we're going to go to 0 with a limit. Now, because we're going from 0 to 2, and visually it looks like this, from 0 to 2, because I'm dealing with the area from 0 to 2, oh, we'll just do it like that, of some function 1 over x cubed, it looks something like this. As I do that, I have no choice but to approach 0 from the right. So this is the limit as a approaches 0 from the right. That might become important later on. Well, it will become important later on. So from a to 2, let's just go ahead and call it what it is. That's x to the negative third dx. That'll make it much easier to integrate, and we'll proceed from here. So here we go. Let's take an antiderivative of x to the negative third. That would be x to the negative 2. 1 divided by negative 2 is going to give me negative 1/2. I left my limit off. Please don't hit me. A to 2, and let's put that limit back in there, and let's switch markers too, because this marker is just not as good as this marker. Told you. The limit as a approaches 0 from the right. Okay, so we're now we're ready to plug a 2 in, plug an a in, figure this thing out. So let's go. The limit as a approaches 0 from the right of negative 1/2 x to the negative 2, that's going to be x squared. So x squared. I'm going to go ahead and do a little rewrite on it. Let's do it like that. It's just going to make it easier to deal with later. So that's what I'm really dealing with. Put the negative exponent back where it belongs. And we'll have the limit as a approaches 0 from the right of negative 1 over 2 times 2 squared. That'll be negative 1/8. Minus negative 1 over 2a squared. Okay, that's what we have. So here's what we're dealing with. Again, negative 1/8. And now we have this situation where we are approaching 0 from the right. So we have positive numbers. If you plug in smaller and smaller positive numbers, approaching 0 from the right, in for a, you're going to have a fraction that's going to get larger and larger and larger and larger. So you're basically going to have negative 1/8 plus infinity. Does not exist. Sorry, does not exist. You could say it's infinity if you want to get technical. Approaches infinity. This equals infinity. It's an infinite area from 0 to 2. I mean, that's finite. But up here, this asymptote, it's just going to go forever. And the contour of this graph is just right or just wrong to where this actually does not exist. So it does not exist. I'm going to reword that. This integral diverges. You cannot say that it approaches a specific number. It diverges from the number rather than converging to an actual area, a number. So D and E, the integral converges. You don't have to write all of that. I'm just throwing in some vocabulary for you. The integral diverges. So sometimes the question will say, does the integral converge or diverge? And what does it converge to? What does it well, it wouldn't diverge to anything, infinity or negative infinity, I guess. But what would it converge to? But this one diverges.